Nitromethane and carboxylates have resonance forms that are equivalent to each other. But this isn't always the case, and sometimes resonance forms are non-equivalent. Here we have acetone. If we expose it to a strong base, we'll remove a proton, and this will leave behind a negative charge on the carbon. When we have a negative charge on the carbon, this is called a carbanion. But this is not the only resonance form. If we move electrons in a similar way to what we saw with nitromethane and carboxylates, this will produce the negative charge on the oxygen. The resulting structure is called an enolate. So the question is, are these resonance forms equivalent or non-equivalent? Another way of saying it is, are they of the same stability or are they of different stability? Well, the answer is that the enolate is more stable. It is the main resonance form. Why is this? Well, we've just got to recall electronegativity. So oxygen is a more electronegative atom than carbon. And so when there's a negative charge on oxygen, it's more stable as a result. We can also depict the carbanion enolate forms in a more abbreviated manner. Notice here that some of the carbons don't have the letter C, and we're not drawing all the hydrogens. Another example of resonance is benzene. Here we have a 6-membered ring with 3 double bonds and 3 single bonds that alternate. If we take the electrons of the double bond and move them onto the single bond, the double bond will become a single bond and the single bond correspondingly will become a double bond, and thus we will produce a second resonance form. Now, the question here is, are the two resonance forms equivalent? Well, they are in this case. So, is this real? And again, the answer is no, because what we're trying to represent, if we were to take a look at real benzene, would be a cloud of electrons above and below the ring. We are smearing the double bond electrons, and so none of these bonds have a double bond length, none of them have a single bond length, and they're all somewhere in between those two. The truth of a benzene ring sometimes is drawn with a circle, and so this is hinting at that smearing of the electrons. When we smear electrons or spread electrons over more atoms and more bonds, the molecule will have greater stability. We can infer that stability with our resonance form methodology by counting the number of resonance forms. The more resonance forms, the more stable the molecule is.